this is basically a transport of services over optical networks. It goes under the G709 ITU-T specification. It is actually not only the G709. There is a huge bunch of documents that you can find on the ITU in the ITU standardization that are about OTN and about the different facets of the OTN technology. The key word here is standard. ITU-T is creating standards, so it is a standard way of mapping, a standard way of multiplexing, it's a standard way of switching, it has a standardized OIM, it also provides a very good support for multi-domain functionalities. It was mentioned already that it is integration of digital and optical layers, so there is a digital layer and there is an optical layer standardized. So the digital layer looks horribly similar to Sonnet SDH, something that legacy networks people know very well. And then there has been an attempt to standardize also the optical layer, so that we have layering there as well. There is also header envisioned for that layer in order to be controlled and so on. This is as much as I will go into the OTN as a technology as such. In the first deliverable in this task, there is a very big section about OTN and the very in-depth analysis of and description what it is and what it is not, so you can see it there. The only other thing that I'm going to tell about the OTN is this very flexible client signal mapping that I was talking about. There are all those client signals that are many different types of signals that you can actually map and multiplex within the OTN hierarchy, and you can carry everything from 1 gigabit Ethernet signal all the way to 100 gig signal, and probably soon even beyond that. The benefits that we saw, the things that we thought that was like, wow, this is very interesting, let's take a look at this, was first this flexible mapping of signals, this all client promise that was given by OTN. So it was basically, let's see really, can we really put whatever kind of client interface and just map it into some kind of standard transport entity that they're providing. That was one of the things we wanted to test and to see. Okay, they say that it stays in the standard. Are there boxes that are doing it? The next one was this multi-level switching, and basically switching at whichever granularity. We already heard that the OTN has layers even within itself, the different ODU layers that you can have, and also you have an optical layer. So if we have a very nice OTN network where you have a lot of different types of clients getting into this OTN box, and can we just get out a single flow and handle it flexibly and dynamically within the network, and how heavy that is, how expensive that is, how easy that is, and are there any boxes out there that are supporting it. The next thing that was very, very interesting, especially from the multi-domain perspective, was this tandem connection monitoring functionality. And this is basically a way of monitoring the health of a signal from end to end. You can set up different segments for monitoring, you can have different layers of these TCMs, and you can basically very easily verify the quality of the signal. You can verify service levels agreements, you can pinpoint exactly where the errors in the networks are, if there is an error somewhere within a domain or between the domains, depending how you have set up your TCMs, you can very easily just pinpoint it's over there. And you can also create some very fancy hierarchies with these TCMs. This we could not test, but it would be really very interesting to see if that could actually happen somewhere, and have a lot more networks and really have this multi-domain, multi-vendor, multi-layer environment that we can test all these very fancy tandem connection monitoring features. I also want to say here that this tandem connection monitoring also comes into play when we're supporting different types of survivability, so it's a very powerful tool for management of your connections. Talking about this protection and restoration and survivability in general, the ODUK, basically the digital layer survivability, is well standardized. There are different SNC schemes that are supported. There are also APS-based schemes. There is a very huge field with for the APS protocol in the ODU header, and also, as I said, this TCM-based survivability or protection, where you can switch based on just the degrading of the signal quality within the responsible section that is failing. Also, while we were researching the field, first of all, to see what we wanted to test, there was something very interesting I found. There was some talks about optical channel and optical multiplex section protection. These are schemes for protection at the analog layer. So here we would be switching wavelengths, not at the ODU layer, but on the optical channel layer. And at the time, a year and a half ago, it was still work in progress. I haven't looked into it to see if things are further developed or not. But the main challenge at that point was the APS channel implementation, because this non-associated overhead was not standardized, and people were not really sure how exactly to make the APS channel to work. But we really wanted to see this. We unfortunately couldn't, because, yeah, as could be seen, not standardized work. So going to the control plane, as we already heard, GMPLS is everywhere, everybody's using it, automatic topology discovery and so on, protection and restoration, and bandwidth on demand. So this whole vertical integration across layers, is that actually the vertical integration across layers, is it commonly used? I mean, you can have IP over whatever controlled with GMPLS, or GMPLS is just for the IP layer, or just for one of the layers?
GMPLS just in the optical or in the OTN and optical layers.
Oh, okay.
Not so much IP and IP too.
Okay, so yeah.
The vertical integration in IETF terms would be the MRN, multi-region networks.
Yeah.
I think that's what you mean. I'm not sure.
Yeah, but the question is, do they have it, or is it still the Chimera part?
And who is they?
People in the networks out there in the real world.
I'm not sure whether you sold it or who have it.
Okay, but is it used? Okay, let's go first. Okay,
I mean,
you don't.
First
Yeah.
need to build it, then
Yeah.
you try to sell it, and then you sell it. So
Yeah.
I know we built it, and
Okay.
I think we're on the selling part now.
Okay, so it will be interesting. Yeah, as we know, it is going to bring a lot of advantages for managing the network, and these famous capex and opex savings that everybody is expecting from these control plane functionalities. So these were the benefits that we were focusing on, that we were interested in, and then we decided, okay, these are going to be the things we are going to try to test with whatever is existing as a hardware in the field. How we saw this OTN architecture fitting within the NRAN, of course, there could be many different ways of applying the OTN. I mean, OTN just as a digital wrapper, if you want, without all the switching and multiplexing and all those fancy things. But one of the strongest features of OTN could very well come in handy with within the GIAN network and within the NRAN communities in general, by using really this standardized network-to-network interface between the domains for this very fast and very seamless establishment of connection across borders, so that you can have more ease in your service establishment procedure. Then this extended OM across the borders, this would be a very, we have already heard today about OM features of different technologies. So the OM of OTN is really very attractive when it comes to multi-domain networks. And then this advanced multiplexing and switching, it provides this very flexible handling of traffic. So if you have an OTN exchange point to which a lot of domains, different NRANs are interconnected, you can have actually a central point where you can have a lot of functionality integrated there, and just dispatch traffic wherever it needs to go in a very fast way and very efficient way. And of course, this multi-level TCM, within the group that we worked with this, we were very fascinated about it. We were like, wow, this is really cool. This could be really great function that you can have in a multi-domain environment if it can really be implemented as it is envisioned. So the tests that we went through, first we went through some client mapping and ODU switching tests with a specific focus on the ODU 0, the 1 gigabit Ethernet signal, and the ODU flex, this promise for whatever kind of bit rate we can map it for you. And also this subflow switching and multi-stage multiplexing was also successfully demonstrated to us. Then we did quite extensive survivability demonstrations and testings with different types of protection and restoration. There was a mesh restoration and control plane assisted survivability. It was really very interesting and very valuable to know that it actually, these boxes, they support these very important functionalities. Then we looked at this cross-domain OM with the tandem connection monitoring, and we were very also, it was very interesting to see the different views of the different vendors, how they saw this functionality and how they implemented it, and that there was some kind of differences, I might say, how they understood the applicability of this TCM. And then, of course, the GMPLS control plane support was also tested and kind of verified in different scenarios. The test setups, as I said, we tested 3 different vendors, and considering the amount of hardware that was available in the labs and the setups, we couldn't really make super elaborate mesh networks. With ADVA and NSN, there was this basically ring topologies that we could test, and with Ciano, the guys could test a little bit more meshy interconnections, and this is where we also tested the switching functionalities. So, test results. Mapping client signals. There is quite a lot of information in the final deliverable. You can take a look exactly what they mapped in, exactly what they mapped it. And what I wanted to say here is that the different mapping and framing procedures were successfully demonstrated, and there was the audio 0 that was successfully demonstrated. Fortunately, the flex was not available at that time. It actually neither of the vendors. I'm not sure how far things have reached. That was about a year ago, so I would assume that audio flex is already up and running and very well functional. Not yet, okay. I can see here some people giving. Yeah, it's but it is in the roadmap, so to say. And there was a demo that was illustrated. So my colleagues from the working group here, they were really very happy to see that something is being done. And then there was this audio switching and multi-stage mapping, and a little bit more this flexible handling of individual audio flows within the network was also very interesting for them to see. There was this very simple topology where there were only these 3 audio OTN switches, and then a signal, an audio 0 signal was mapped multiple paths, basically into audio 1 and audio 2 and audio 3, and the audio 0 was actually switched within the intermediate nodes here. So the guys were very happy to see this. Okay, yes, there is real switching going on there, and things are working as they should be. So as a conclusions, functionalities, they were according to standardization, or at least as much as we understood from the standardization. We were very pleased to see whatever we saw. This most promising feature of AudioFlex was not really plain shown to us, but it was in the roadmaps, and as we can hear from my left-hand side, it is already there. And it was quite clear that this very flexible way of handling traffic was very attractive indeed, and the guys from the test, they were very excited to see this high bandwidth and dynamic way of handling traffic that was really very promising for the NREN community as we saw it. So next test that we did was survivability. It was very interesting indeed to see there were many different standardized schemes of the audio K level that were showed. The most interesting one, of course, the one based on the TCM, the tandem connection monitoring, where the tandem connection monitoring was actually providing the signal failure and signal degrade alarms. So for multi-domain environments, I will probably tell it 20 times until the end of this presentation. We're very excited about it. It really provides a multi-domain, a true multi-domain operation, as it could be seen. And then there were several types of this control plane assisted restoration, and some of the most interesting things that we saw was actually that there was this possibility for a dynamic control of the restoration path, and that the administrator of the network could actually set up different costs that could be based on some kind of administrative normal cost or delay measurements, which was very interesting to see, and switch the traffic on a backup path that was compliant with the delay requirements of the application. There was also, as far as I understood, a situation where you could switch a traffic to a backup path based on monitoring the delay of the original path. So if it starts degrading somehow, you could switch to another backup path. So this, for delay sensitive services, this sounds extremely promising. And there was also a very interesting hybrid protection / restoration scheme that was illustrated, where there is a pre-computed protection path, and when a failure happens in the working path, the traffic is switched to the protection path, of course, and at the same time, dynamically, the control plane will provision another protection path. So at any time, the working path will always have at least one protection path pending for possible usage. So it is, and it all happens basically automatically. You don't really need to do anything in the network. Things are set up automatically. So the conclusions from that work was that the standardized audio case survivability was as expected, as standardized. And the very attractive features of this control plane assisted survivability was very nice to see and to experience. These mesh-based recovery schemes where there is an explicit control of the backup path, and where you could tailor your backup path to meet your signal requirements or your service requirements was also possible. It was also automatic, so it's supposed to be saving some operational expenses there. And the combined schemes, of course, provide a lot of flexibility. The next thing was the tandem connection monitoring. As I said, we didn't have a lot of boxes to test with, so we didn't manage to make very elaborated topologies for this multi-domain OAM test. So we had only two we could configure 2 domains that were interconnected, so we can have different tandem connection monitorings within each domain, and from end to end. And also there was one actually here. It's not shown in the figure. There was a TCM here. And then we we introduced errors in different parts of the network, in the client or within each domain or within both domains. Then we observed to see, okay, will these TCM indicators really lead us to directly point which part of the network, which segment is important for that particular error that is happening in the network. And surprise, surprise, there was extremely clear indication who was responsible for the errors. I mean, there was, without any doubt, you could say, okay, this is domain A, this is domain B, this is the inter-domain link, or whatever. You knew where the error was. So there was no more pointing fingers, exactly, it's your fault, no, it's my fault, but everything is fine in my side, and so on. You could see it. A challenge that we saw was that this multi-domain TCM, it actually requires a cooperative planning and deployment. So you cannot just decide, okay, I will have a multi-domain connection, and I would like a TCMs here, 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 and there. I mean, you cannot. I mean, you have to talk to the other domains and arrange this together. So it could be a little bit complex, and it's a non-standardized procedure, so it requires some talking about it. So I also mentioned this a little bit different view about how what these TCMs are about and their applicability. So there could be some multi-vendor issues there as well. We tried it only within one vendor, so I don't know what will happen if we have different vendors within the different domains. It will be very interesting to see. Test results with respect to GMPLS, what we did was that we actually performed some topology discovery, some automatic provisioning, and tear down of connections, and some automatic restoration. We gather up a lot of packet traces, and we analyze them basically to see, okay, what is going on in the network? Is there really a GMPLS control plane behind, or things are happening in a different way? So what we saw was, yes, of course, a lot of OSPF packets and a lot of RSVP packets flying here and there. Most of them were as by standard, as at least as much as we understand what the standard is. And there, of course, were some added proprietary features, and that is quite understandable. This differentiates vendors on the market, these special tweaks that they have within their nodes. But it also will pave the road towards interoperability issues. I'm quite aware that there are a lot of multi-vendor interoperability demonstrations also for the control planes, for the data planes, and so on. So it is being worked out, these potential issues. They are probably already, a lot of those are being caught up and fixed, but it still needs to, I mean, you must be sure that whoever you're interconnecting with have a compliant GMPLS with your GMPLS, let's say it like this. But it is a great tool for this integrated cross-layer and cross-domain and cross-technology and cross-everything environment that we're having in the NRAN network. So it, this operational intelligence is very valuable. So the discussion tomorrow, it would be very interesting if, of course, a lot of people were asking at the beginning, okay, OTN, NRANs, I mean, seriously? I mean, is this a serious technology? Is this a needed technology for the NRAN environment? And that's a very good question. And the only person that can answer that is you yourselves. You know your networks, you know your services, you know your clients, you know your future predictions for future services. So when tomorrow you start designing the next Jiang or trying to figure out what kind of technologies to deploy, try to answer yourselves, is OTN really relevant? Because it could be really great, all these features that we showed, but it might not be something for your own network. So you should consider this. Is it internally for you? Should you deploy it? Does it make sense? Also with respect to serving future clients, maybe future services that you might provide in your network. And also with respect to this multi-NRAN environment that you're having. Okay, you're, but my network is my network, your network is your network. How can we glue those two together and make them talk together and operate in a seamless way? Which of these functionalities are important, which are interesting, which are completely irrelevant, that they are not applicable in your network? So this is a very good question when you're trying to design, of course, your next platform for your network. And of course, as we saw in our slide number, I don't know, 7 or something, our suggestion for the OTN within the NRAN environment, might OTN be relevant for the GIAN as a backbone network? Maybe this should be the gluing technology that is gluing everybody else's. I mean, somebody are running PBBT and somebody are running MPLS or whatever kind of technologies you're having. Could this OTN be the common glue between all your different technologies that you're having? So, as a summary, it's highly scalable and supposed to be future-proof technology. It is having this unprecedented client signal mapping. It promises to map everything into its containers in a very effective and efficient way. These advanced OIMNP functionalities are really very valuable if you need them. And of course, this GMPLS readiness, this control plane readiness is also very important. We have this solution as a very nice multi-domain service provisioning platform. And as we said, major vendors are already having these features. So it's not something far in the future. It's standardized, it's out there. I'd like to thank the contributors for their contributions, for their help here. And of course, we have a nice white paper and the final deliverable that you can find in the Jan 3 site. If you're more interested in exactly what we have tested and how we have tested it, you're welcome to take a look. So, thank you. Yes?
Ready for questions?
Yes, yes.
Okay. Yes, well, I can answer at least one of the questions you put up, which is the role of GMPLS and restoration in the general backbone. And the answer is very simple, and it's yes, we will be turning it on, and it will be very useful for us. There are many scenarios, and perhaps we can talk through those tomorrow, where it's going to be a very useful feature. So it will be turned on when it's installed in the next few months.
Okay. Any other comments, questions? No?
Okay, next speaker is Rasmus Løg, presenting the work done on Alien Waker through entire SHA-3 and also the work done in the year 4 of SHA-3 with the focus on OM aspects of the Alien
Thank you. Lars? There's no power on this one? Okay. See if it works anyway.